Hello everyone, welcome back to Technologies Discussion Channel. For this video, I'd like to continue the discussion on EMC. To be more precise, this video, I'm going to explain what is actually happening inside an EMI compliant lab. To be more precise, how radiant emission is actually executed in this semi-anechoic chamber to test for electronic product. So this will be the objective of this video. Guys, this is my email. If you have any question regards on this discussion, please drop me an email. Okay, or if not, I actually prefer you guys to ask me your question through the comment. Let's start. Radiated emission in a lab test environment. Okay, so this diagram here show a semi-anechoic chamber. Okay, so basically this is a lab test environment. Okay, they actually refer to unwanted electromagnetic energy that a device actually emit into the air. For example, this is your DUT. Okay, basically this DUT emitted unwanted electromagnetic energy without you knowing. Okay, so basically this emitted unwanted EM wave basically will cause some form of interference with radio, Wi-Fi, GPS, or even medical device. Basically, this is undesired. So basically, in this lab test environment, we want to measure the unwanted EM wave that is radiated by your DUT. What is being measured in a radiant emission in a lab test environment? Any electronics device, in order for them to work, they definitely need to generate electrical signals. These signals can unintentionally act like a radio transmitter. Let's say if current flow through cables, they can be like an antenna. Radiation actually occur. And again, you can imagine current flow through PCB trays or current flow through metal structures. Again, this can be like an antenna radiate out, which is undesired. During a radiant emission test, what the engineer need to do is they actually firstly measure the strength of electromagnetic energy that is actually emitted by the DUT. Next, the frequency at which emission actually occur. From this diagram here, you can see that these are all the electromagnetic field strength that is actually emitted out by the device. This is actually the frequency. So from here, okay, you can clearly see that which frequency, basically the strength of the electromagnetic field is actually big. So next, okay, we need to know whether the emission stay below the regularity limits. This is actually the limit line. Okay, we need to ensure that whatever that we measure must be below the limit line. The result is usually expressed in units such as dBµV per meter, okay, which is decibel relative to 1 microvolt per meter. So this is what being measured in a radiant emission in a lab test environment. Firstly, we measure the strength of the EM field and then also the frequency which they actually occur. Then we need to ensure that all these emission actually stay below the limit line in order to certify this device actually passed the EMC test in a lab test environment. Let me explain the typical lab setup for radiant emission. Okay, so a radiant emission test is usually performed in a semi-anechoic chamber. Okay, so this diagram here show a semi-anechoic chamber. How we know? Basically on the floor here, basically without absorber. So therefore we know this as semi-anechoic chamber. If let's say on the floor there is actually absorber, then we call this so-called anechoic chamber. So this is the difference between semi and fully anechoic chamber. Okay, so this chamber here, mainly the key purpose is to block outside radio frequency signal, which means that the signal outside this chamber will not be able to enter into this chamber. And on the other side, okay, whatever that is actually inside this chamber will not be able to escape through this chamber. So basically, this is actually the lab setup in a semi-anechoic chamber. Next, the setup include, okay, firstly is the DUT. Okay, so basically you can see that this is where you position your DUT. This is the device being tested. Next, non-conductive turntable. Okay, so basically you can see that this is actually a non-conductive material, cannot be metal. What they actually do is they rotate the device 360 degrees. Next, the measurement antenna actually receive the EM wave. Okay, so basically you put your device over here, and basically you can imagine that they release the electromagnetic energy. And you can see that this is actually the antenna. The antenna actually will pick up the electromagnetic wave that is actually released by your DUT. Next, okay, so the EMI receiver or spectrum analyzer will help to measure the signal strength. Okay, over here, okay, you probably can see some test and measurement equipment, or even sometimes, okay, the test and measurement can be outside this chamber. So in short, okay, we need both the EMI receiver and spectrum analyzer to conduct the radiate emission test. Next, absorber line wall, okay, they actually minimize the reflection for accurate measurement. So in short, okay, you know that EM wave, they basically will transmit and they probably will bounce. And you can imagine that the EM wave basically bounce to and fro continuously. So with absorber, they actually minimize the reflection as much as possible. So therefore, we need the absorber because in EMC, we just want to measure the direct path from the DUT all the way to the antenna. Okay, so next, the antenna height is often vary. Okay, so basically you can see from here, the height of the antenna often vary. In short, they actually vary from 1 to 4 meter, while the turntable actually rotate to find the maximum emission. Imagine your DUT here, they will rotate 360 degrees to find the maximum emission that the DUT actually occur. So this is a typical lab setup for radiate emission. You probably will ask why we need to rotate the DUT. Okay, because the amount of radiation actually depends on the orientation of the device. For example, okay, a cable may behave like an antenna in one direction. Okay, basically this is, let's say, a very directive antenna. They basically only radiate in one direction. So basically without rotation, we are not able to find that particular direction that the antenna actually radiate up. Next, the PCB layout may radiate more strongly from one side. So basically with this, again, you can imagine that we need to rotate your DUT. Okay, so therefore, the facing, okay, that have the most radiation will be measured with the antenna. So this two is actually the key reason why the device need to be rotated. So besides rotate the device, okay, we also need to adjust the antenna height. As I mentioned earlier on, we need to adjust the antenna height from 1 meter to 4 meter. So in short, we want to find the combination of the rotation, which angle, and also which height that were able to capture the worst case emission by your DUT. Next, let me explain the frequency range of testing. In fact, different standard actually specify different range of frequency, but common testing actually cover basically in two. Basically the 30 megahertz to 1 gigahertz, which is very, very common standard. Okay, so basically it mentioned also over here. Nowadays, because we move to higher frequency, so therefore above 1 gigahertz up to 6 gigahertz, which is also very popular. If let's say your device work in a higher frequency, then you need to test them with higher frequency. So basically, this is the frequency range that you actually need to test for product. Let's say that they are actually high-speed digital electronics or some wireless function, then you need to consider to test them at a higher frequency. From this diagram here, okay, you can see that mainly is from 30 megahertz to 1 gigahertz testing. As I mentioned, this is very, very common for a lot of standard. And recently, okay, because as I mentioned earlier on, we moved to higher frequency. So therefore, we also need to test the higher frequency of emission by radiate emission. Next, let me explain why it is so important, okay, to conduct radiate emission testing. So in short, radiate emission testing actually help to ensure, okay, the device do not interfere with nearby electronics device. So another reason is whatever DUT that you newly develop, they must actually compliant with regulation, okay, such as those from regulatory agency in different region. For example, in Singapore, okay, we have this IMDA. So therefore, any new product, we need to ensure that they actually meet the criteria. Next, multiple electronics product can actually operate together. So imagine there is no one electronics device. Nowadays, we have a lot of electronics product, they actually work together. So therefore, in order to ensure that multiple electronics product are able to operate together, we need to conduct such tests. So in short, radiate emission testing is essential, measuring how much unintended radio noise a device actually leak into the surrounding air under the control lab condition. As you can see from here, this is actually the control lab condition. Basically, the DUT actually emit up a EM wave. They basically measure by this antenna, and then they pass it on to the spectrum analyzer or EMI, and basically they actually show how much is actually the EM wave that is actually released by the DUT. So this is why it is so important to conduct radiate emission. So in short, this actually allow multiple electronic products to operate together. Coming to the objective of radiate emission tests. So in short, they actually measure the electromagnetic energy that is unintentionally emitted up by your DUT, and they basically determine whether it can compliant with the limit line that is actually defined by EMC standard. The procedure is designed to find the maximum possible emission from the device under controlled condition. Okay, so like I mentioned early on, we will turn your DUT in a certain phasing that actually obtain the maximum possible emission. And also the antenna will vary from 1 meter to 4 meter in order for them to capture the maximum possible emission. So in short, they actually pick up the maximum possible emission by your DUT with the phasing and also the height of antenna. So this is actually the objective of radiate emission testing. Before I continue, guys, I need your help. Okay, I need your help by like this video. If you have learned something from this video, help me by like this video. If you are encouraging me, okay, so basically help me by subscribing to this channel and turn on your notification bell. Once again, thank you so much for your strong support. Next part of this video, I'm going to explain the test procedure for radiate emission testing. So in short, there are actually 9 steps, okay, for me to explain. Firstly, okay, prepare the DUT, okay, or EUT, equipment under test. Okay, so basically the device is actually configured in a representative operating mode. So basically imagine this is your device. Okay, you need to power up as its intent operating mode. So basically you need to power by its normal power source. Okay, let's say by battery, let's say by power source, okay, the AC source, you need to power up your DUT by the normal power source. Next, you need to run software or function that create the highest activity. Okay, so basically, in short, you can imagine that your DUT, okay, will be function at the max capability possible. Okay, so if you still recall, for example, some years ago, Volkswagen actually test their car, okay, not under the highest activity. This become a big issue because without being the highest activity, you can imagine that the emission will be at the lower as compared to the highest activity. So therefore, we need to run all possible software or all possible function that can create the highest activity. Next, okay, the device here, okay, they connect to all the required supporting peripherals and also the cables. Next, okay, the test need to be continuous operating through the test, okay, which means that they cannot be just transmit for one time, after that, they will go to sleep. Okay, so you need to ensure that they will be continuous operating throughout the test. So in short, the goal is to create a worst case emission scenario, which I explained earlier on. After you have done with your EUT, next you need to set up the test environment. Okay, the EUT is basically placed on a non-conductive table. Okay, so basically this is actually a non-conductive table. You put your EUT here. Okay, so basically they are actually located inside a semi-anechoic chamber, as you can see from here. Okay, or an open area test site. Okay, so this is pretty rare now. Okay, because we have a lot of signal, cellular signal, etc. So therefore, it is very challenging to conduct radiate emission in an open area test site now. Okay, so rather than that, most of the time, I believe that we actually do the radiate emission testing in a semi-anechoic chamber. Let's come to the typical arrangement. The table is placed on a rotating turntable. Okay, so basically this is actually the rotating turntable. Okay, the table will not rotate. Okay, basically this thing actually rotate and the table will also rotate. A receiving antenna, okay, basically is positioned several meters away from the EUT. So from here you can see that they are actually placed 10 meters away. Okay, the antenna is here. They are actually placed 10 meters away from the EUT. Okay, but for some testing, it actually require to be apart at 3 meters will do. So depend on different standard. Okay, so basically either 3 or 10 meter will be the standard away from the EUT to the antenna. Next, the chamber wall actually contain a lot of RF absorber. You can see from here. This is to minimize the reflection as much as possible, which I have explained earlier on. Next, they will perform a pre-scan. Okay, so basically it is measured by EMI receiver. Okay, so basically this is a EMI receiver or spectrum analyzer. They basically will perform a wide frequency scan over the required range. Typically, like I mentioned earlier on, from 30 megahertz to 1 gigahertz is a must. So nowadays it can go more than 1 gigahertz. Okay, the system actually record the frequency where emission are detected. This step is relatively fast and identify candidates frequency for detailed measurement. So in short, okay, let me just explain why we need to have these two set of equipment, EMI receiver and spectrum analyzer. Okay, so basically the spectrum analyzer measure much faster as compared to the EMI receiver. So therefore, at the pre-scan, majority of the tasks will be measured by spectrum analyzer. Let's say you need to do some detailed analysis, then the signal will so-called route to this EMI receiver. So this is why we need to have these two set of equipment, EMI receiver and spectrum analyzer. In short, spectrum analyzer measure quickly and conclude quickly, but in order to have a more detailed scan, then the signal need to route to this EMI receiver. Step 4 and 5, which I have discussed earlier on. Step 4, rotate the device. Why? Okay, basically different orientation. They probably may produce different radiation pattern. So therefore, we need to rotate so that the maximum emission can actually pick up because any angle can have the maximum emission. So in order to achieve this, the turntable need to slowly rotate through 360 degrees. Next, 5, change the antenna height. The receiving antenna basically will be raised and lower from 1 meter to 4 meter, okay, while observing each emission frequency. They will find the position, okay, the position of the height of the antenna that actually produce the strongest receiver signal from the spectral analyzer, okay, or the EMI receiver. Next, change the antenna polarization. So in short, we have the horizontal. Okay, so basically, this is the horizontal polarization of the antenna. We also have the vertical polarization. So therefore, we need to change the antenna polarization when we actually conduct the radiate emission test. Okay, why? Okay, because some emission are stronger in one polarization than the other. So the key word is we want to capture the worst case. So therefore, we need to change the antenna polarization. So this is what I mentioned earlier on. We need to maximize each emission measurement. So for every significant emission, okay, we rotate the DUT in order to have the worst phasing. Next, we will adjust the antenna height so that the EM pick up by the so-called spectrum analyzer or EMI receiver will be the highest. We also will change the antenna polarization. So therefore, okay, we will keep doing this treating until we pick up the strongest EM wave that is actually emitted up by the DUT. Next, move cable if allowed by the standard. Okay, so basically, for example, there are different cable. Okay, you need to standardize how you actually want to place the cable. The key objective is always determine the maximum possible field strength that is actually released by the DUT. Let me come to the final measurement. After getting the maximum worst case emission by the EUT, okay, so basically we are actually going to use three types of detector. Okay, the peak detector, quasi-peak detector, or average detector. Basically, different standard actually require different detectors. This video, unfortunately, I'm not able to explain the three different types of detector. Okay, but the key purpose is every standard actually require different set of detector. So therefore, we need to use the so-called required detector in order to perform the final measurement. Okay, so basically this is what I mentioned here. Different standard actually require different detector types. So this is step number 8, final measurement for radiate emission testing. The last step, compare with the limit line. Okay, so basically the measured field strength. Okay, so basically this is actually the measured field strength. They are typically in dB microvolt per meter, as you can see from here. They are actually compared against the limit line. Okay, so the red color is actually the limit line. I would say that different standard will have different limit line. So this is just one of the standard with the limit line. For example, okay, if the emission actually exceed the limit line, okay, the device does not pass the radiate emission test. So this is my last step, is to compare your measured field strength against the limit line. If it's more than the limit line, then the device does not pass the radiate emission test. My last slide for this radiate emission testing procedure. Okay, so basically these are the 9 steps that I mentioned earlier on. First one, configure the device in the normal under the worst case possible operation. Next, place your DUT on a rotating table in a controlled EMC test chamber. Next, the device will scan across the required frequency range. Typically, it must be at least 1 gigahertz. Nowadays, we move to a higher frequency. We also need to test at a higher frequency. Next, rotate the device 360 degrees. Vary the antenna height from 1 meter to 4 meter. We measure both the horizontal and vertical polarization of the antenna. We maximize each detect emission. So basically these three things, okay, we basically want to find the maximum possible emission by the DUT. We record the highest value, okay, under the measure. Then last but not least, we compare the result against the standard, against the limit line to determine whether the DUT pass or fail the test. So this process actually ensure that the device strongest unintended electromagnetic emission are evaluated under repeatable laboratory condition. With this, I'd like to end my discussion. If you have learned something from this video, help me to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.